Okay, hi guys. So we're going to be going over the Red40 standard curve datasheet. This is due at the beginning of lab in week 5, which is this week. So here we see these are my absorbance values that I did it when I got my spec work done. So for tube 0 through 6, 6 is the most concentrated, it's at 20 micrograms per mil. And then as we step down per tube, it goes to 10, 5, 2.5, 1.25, 0.625 micrograms per mil. So each step is a half, right? Because 10 is half of 20, 5 is half of 10. And you see about those same patterns resembled in the absorbance readings. So this is about double of this one, this is about double of this one, and so on. Now, single step dilution and serial dilution should give you about the same absorbance readings. Mine aren't exactly the same. There's some variation, as you see. That depends on the spec and the accuracy of the pipettes and your diluting, but they are pretty close. So the first thing we have to do is we have to create a standard curve. And the standard curve is when we have known concentrations, which you do. We have a known concentration of Red40 to make these dilutions. So now we're going to make a standard curve in order to plug in values that we find for our unknowns to solve for the concentration. So these are the values that I got for my standard curve. This is the equation that I made. The way you do that is if you go to Excel, okay, that was for setting up the standard curve. Moving on to the unknown Red40 sample, this was when you took the most concentrated Red40 and you made a dilution, and you're supposed to keep track of how many dilution factors or how many types of dilutions you did, and the absorbance value of your final diluted unknown Red40 sample. So when I did this, I did a 1 to 4 dilution, and if you just move this into decimal form, 1 over 4 is 0.25, and my absorbance value of the diluted unknown Red40 sample was 0.347. So for number 3, we have to use the trendline equations above, these ones, to solve for the final concentration of Red40 after dilution. So this is after dilution, right? So we're going to be using the diluted unknown Red40 sample. So this is an absorbance value. Y is equal to absorbance. So you plug 0.347, but using your value, into this equation. So 0.347 will be equal to y, and then you solve for x. Now make sure to use your own values here, okay guys? And when you solve for x, you're going to be solving for concentration. And you do this twice. You do it for the CF, which is the concentration final for the single step. And so it's concentration final because it's diluted, so that's the final concentration that you were at. So for mine, it was 5.996 micrograms per milliliter. Make sure to write units. And then for the cereal, I just plugged this number into the cereal dilution trend line. I got 5.790 micrograms per milliliter. So these values are not exact, but they're very similar. And so for number 4, the answer is yes, they are close in value. And the difference could contribute to several things. It could be pipetting error, or that's pipetting error on my part or on the part of the pipette itself. It could be the difference in the spec, and several other reasons that I mentioned in class. So why don't you guys try to think of some of those and put those for your answer. Okay, so then for number 5, we use the DF, which is the dilution factor that we determined in step 1. Remember, that's up here. For me, it was a 1 in 4 dilution, so my DF, or dilution factor, was 0.25. So the equation is, okay, so first of all, for number 5, we're trying to solve for the initial concentration, which is CI. And the way that you do that, the equation is CI is equal to CF divided by DF. So CI is initial concentration, the most concentrated, is equal to concentration final, which is the most diluted, divided by the dilution factor. So remember my numbers from earlier. If we just plug that into the equation, so we have CI is equal to, this is my value from up here, this one. So CF divided by DF, and that will give me this. Now this is the same thing as just multiplying your CF, your concentration final, by the dilution factor, if that makes more sense to you. So for example, up here, like 1/4 is equal to 0.25, you could just multiply this value by 4 and it'd be the same thing. Alright, and the final step of this lab was finding the unknown concentrations of soft drinks, or finding the concentration of unknown soft drinks. So I just made up all of these numbers for reference, so you guys are going to have to use all of your information, including the type and brand and the dilution factor and your absorbance value, so make sure to use your own data. So for beverage 1, the type and brand was Coke, and the dilution factor, for example, was 1 to 10, and that in decimal form is 0.1. And the absorbance that I got for that was 0.259. So now the way you solve this is the exact same way you did it before. So solving for the CF, which remember we did up here, right? We have to use, wait, hold on, let me go back up. Okay, so for the CF, you plug the absorbance into the trend line. So for this one, for the single step, you plug 0.259 into the single step trend line. And then you also plug the 0.259 into the cereal step. The cereal dilution trend line. Okay, so that's for CF, because that's the concentration final. That's the most diluted, so you're plugging this absorbance value into the Y to solve for X to get the CF single step and the CF cereal. And then from both the CF single step and CF cereal, you multiply that by the dilution factor, which is 10, or if you follow the equation, which is the right way to do it, you do CI is equal to CF divided by the dilution factor, which in this case is move the decimal point over 1 because it's 10. I'll go through that one more time. So the equation right here is CI is equal to CF divided by DF. So CI is equal to CF divided by DF. And then you do the same thing for beverage number 2. Now 7 and 8 is up to you guys. It's answering questions based on your personal lab, so I'll let you guys go ahead and do that. The beginning of lab on Thursday, turn in the final copy of this along with printouts of your Excel graphs. and I will see you tomorrow morning.